Hello, Psych 101 students. I'm back again with the rest of the biopsychology material from chapter 3. I'm going to go ahead and share my screen. And here it is. And we're going to start talking about the brain and the spinal cord, and particularly some areas of the brain. We're going to start with the hindbrain. The hindbrain is kind of sort of to the back of the brain and the top of the spinal cord, and it contains three structures. We talk about it as sort of the old brain in the sense that it has much in common with almost every other animal that has a brain. It does all of our life functions. So a lizard, a chicken will have the same structures, and they'll do very similar things. So, for example, it has the medulla, or as some of you know, as the medulla oblongata. And that is all of our basic life functions like breathing, heart rate, swallowing, sneezing, coughing, vomiting, and things like that. If you don't have the medulla, you are dead. That's basically the deal. The reticular formation also does some very basic functions having to do with sleep and arousal. It wakes us up. It also puts us to sleep. Sometimes damage to the reticular formation can cause a person to go into a sort of a permanent sleep, like a coma. The cerebellum is an area there in pink that looks very much like a very small brain on the back of our brain, and it is involved in movement and memories that have to do with movement. We call these procedural memories. Some of you know these as muscle memories. Maybe the memory for a particular type of dance, or how to dial a certain number on a phone, or how to drive, and things like that. Those are called procedural memories. So the cerebellum is involved in memory. Here we have the medulla coming up here, and the reticular formation coming through in orange there. Now we're going to talk about this part here that's flashing, and it is called the cerebral cortex. It is a newer part of our brain. It has less in common with many other animals because the other animals look different in their cerebral cortex. You notice that ours is really convoluted. There's a lot of bumps and grooves and stuff like that. Not all animals look like that. So this is evolutionarily a little bit newer part of the brain. We're going to talk about some areas of what we call the forebrain, and first being the cerebral cortex. And then we'll get into some of the lobes of the cortex as well. So the cerebral cortex there can be broken down, and on this side is where my eyes would be of the brain. So this is the frontal lobe here. Then we've got the parietal lobe here in the next picture, the occipital lobe, which is going to be on the back of the brain, and then the temporal lobe, which is right around the ears or the temples. The frontal lobe is involved in movement and also language and also reasoning. So all of the movement directions that come from our brain, when I say I'm going to wave my hands, that is coming from directions from the frontal lobe that are going to go down through my spinal cord and then out to my arms. So my frontal lobe is directing all of the movement of my brain. It is also, especially on the left side, if you remember from the last video, involved in language in the brain. And so many people who damage their frontal lobe will have trouble with language, especially if they damage the left frontal lobe. And then finally, reasoning. As you remember from the Phineas Gage story I talked about in class, that the reasoning abilities, the ability to make sense of things, to plan for the future, is affected by damage to the frontal lobe there. So reasoning and logic and things like that. The parietal lobe is involved in body sensations, and it contains a really important strip area here called the somatosensory cortex. And that is where we get all of our body sensations. So the sensations that are coming from my fingers right now, which are feeling a little wind from an open window over here, that is coming into my brain, into that parietal cortex, or parietal lobe of the cortex. And also many other kinds of body sensations. So it would be heat, and temperature and pain, all of that is coming in to the parietal lobe. The occipital lobe here in the back has primarily to do with vision. It contains an area called the visual cortex. If you hit yourself really hard in the back of the head, you might see stars. And it's because it's giving you a visual hallucination because you hit a visual part of the brain. People who damage that part of the brain can't even imagine visual scenes. They, if you try to think of a pink elephant, you can think of a pink elephant right now, even though you're not seeing one. But people who damage that part of the brain can't even imagine anything visual. The temporal lobe is involved in hearing and understanding language. It has the auditory cortex, which is primarily for hearing. So you can remember it because it's right here in the brain, and it also is for hearing. And if you damage that, of course, you're going to lose some hearing and ability perhaps to understand language. Here's some other forebrain structures which are inside. So you can see that cerebral cortex on the outside, and then there are some forebrain structures that are inside underneath the lobes of the cortex. It contains the other inside forebrain structures. The interior ones are mainly about emotion and motivation. So we have an area called the limbic system that is going to be contains the amygdala, hippocampus, hypothalamus, and the thalamus. Let's go through these one at a time. The amygdala is involved in emotion, and particularly fear and aggression. So people who get a tumor in their amygdala, they may be very, very aggressive, also very, very fearful. So your fear, your aggression comes largely from your amygdala of your brain. The hippocampus is involved in memory, and especially for memory of recent kinds of events, like what happened earlier today. And so you can remember this by saying, if a hippo ran across campus today, you would not forget that. The hypothalamus is involved in motivated behaviors. For example, hunger and thirst and sex. And you can remember that by the 4 F's. So we talked about the autonomic nervous system, and particularly the sympathetic nervous system, in the last video. And we talked about how the sympathetic nervous system is going to cause that fight or flight response. Your heart rate goes up, your breathing goes up, you get very aroused. And in fact, the sympathetic nervous system is directed from the hypothalamus. So the hypothalamus, the first 2 F's are fight and flight. So it's involved in fighting, in fleeing, and then also in feeding, and then also involved in sex. So there are your 4 F's. Some of you got the joke. Okay, so the thalamus is a kind of a sensory relay station. And you know that some of the senses go to the lobes of the cortex. For example, the temporal lobe, as I said in the last slide, is for hearing. The occipital lobe is for vision. All of that is going to be routed through the thalamus. So initially, when it comes in through the eyes, it goes to the thalamus. The signal is going to go to the thalamus and then go back to the occipital lobe. Information coming in from the ears, the signal is going to go again to the thalamus and then to the temporal lobe. And that's true of all the senses except smell. Okay, I want to talk about one last thing, which is the endocrine system. The endocrine system is a system that involves glands of the body and also the blood. So we're not talking about the brain here. We're talking about glands within the body, although some are in the brain, and then also in the blood. So let's take a look at those glands. We see that the pineal gland, the hypothalamus, which we talked about, has brain tissue, but it also has endocrine tissue. The pituitary, the thyroid, some of you have heard about these, the thymus, the adrenals, the pancreas, and if you were born with female sex, the ovaries, and if you're born with male sex, the testes. All of these glands will produce hormones, and those are chemicals that are released into the blood. For example, the testes will produce testosterone. The ovaries also produce testosterone. That gets released into the blood. It flows all throughout the body, and it changes a lot of things. And one of the things it can alter is brain function. So in this sense, The glands are releasing hormones into the endocrine system that are going to interact with nervous tissue and change our mental states. So, for example, the adrenal glands can secrete adrenaline, named after the adrenal glands, and that is helping to produce that fight or flight response we talked about earlier with the sympathetic nervous system. The testes will secrete testosterone, and that seems to be involved in aggression and also muscle building and things like that. So this concludes our Chapter 3 lectures. I hope you guys enjoyed these video lectures, and I look forward to hearing your response. Have a great day. Bye-bye.